Hi, everyone, and welcome to FastAPI for Machine Learning, live coding an ML web application. My name is Greg Loughnane, and I'm head of product at FourthBrain. We appreciate you taking the time to join us for this event. We're so glad to see you tuning in from all over the world. If it's late for you, thank you for staying up to join us. Our event today will walk you through how to build your very own AI image generation web application using FastAPI and Stable Diffusion. We're going to get right into it today. If you hear anything during our event that prompts a question you'd like to ask Sebastian, please follow the Slido link in the description box on the YouTube page. If you're just listening, check out the link to see questions others have asked and upvote your favorites. We will do our best to answer the most upvoted questions during the Q&A portion of this event. Without further ado, it's my pleasure to welcome Sebastián Ramírez to the stage. Sebastian, also known as Tiangolo, is the creator of FastAPI, Typer, SQL Model, and other open source tools, mainly using Python. He's currently a senior staff software engineer at Forethought and also helps out other companies as an external consultant. Sebastian, off to you, my friend. Take it away.
Thank you very much. Thank you very much for inviting me. Thank you everyone for being here. So amazing. Let's do it. So what we are gonna do is that we are gonna build we're gonna live code. This live part is freaking me out. So let's hope it goes well. Please help me pray to the gods of live demos. We're gonna live code a machine learning API with FastAPI. So the idea with this FastAPI is that we will get high performance. It's easy to learn. It's fast to code and it's ready for production. So first, who am I? I'm Sebastián Ramírez. I am from Colombia in South America. That's why the accent. But I live in Berlin, Germany. And you can find me online on multiple places. I'm currently working at Forethought, plus I'm working as an external consultant with other companies. And I created a bunch of tools, as Greg was saying. So we're going to talk about FastAPI. First, what is FastAPI? It's a Python web API framework. It currently has 50-something plus K GitHub stars. It's being used by a bunch of cool companies, and the performance is in the top rank of what you can get in Python. So that's quite cool. And it's been one of the most used Python frameworks by the official Python Developer Survey. Is the one with the fastest growth. Is one of the most loved ones from the Stack Overflow Developer Survey. So it's been liked by a bunch of people, unfortunately. So that's why it will be kind of relevant. But then FastAPI for FastAPI for machine learning people is what we are going to talk about. So I will assume that you know machine learning. I won't teach you machine learning. If you don't know machine learning, probably you should go and take one of the courses at deeplearning.ai or with FourthBrain. Like, those are the masters. That's where I started my career with the first course from Andrew Ng on Coursera before it was called Coursera about machine learning, which is now what deep learning is AI is doing. So you should probably go and study that over there. I will assume that you know the basics of web APIs like HTTP, JSON, but we are going to cover all that here live. So this is what we're going to be talking about. Now, FastAPI is based on standards like OpenAPI, JSON schema, OAuth 2. The thing is that it's based on standards and it uses those standards underneath. But the way it's designed is that you don't have to know those standards to be able to take advantage of that. So you get things like automatic API talks, like this, what we see on the side. We're going to see a little bit more about that. And it's all based on the standard Python type annotations. So from the type annotations, you will get auto-completion, inline errors, a bunch of things. But then FastAPI does automatic data validation, automatic data conversion, data validation, and data documentation for you. So you get something that is based on standards for free, which is quite nice. Now, let's start talking and showing slides. Like, we came to live code and get nervous and type typos. So let's just do that. So I have here my editor. And I am in this project that we are going to work. So the first thing that you will have to do is to go and actually let me activate screencast so that you can see the things that I'm typing here. So the first thing that you will do in a project, it will probably be on the command line. You will create a virtual environment. So it will be something like Python -m the end, and then you will type the name of the virtual environment that you want to create. So you're calling Python with the flag -m. This tells, hey, Python, I want you to use the module called venv. Venv is part of the Python standard library. And then we're telling it what is the directory that we want it to use to create the virtual environment. I already ran this command, so I already have the virtual environment here. Then the next thing that you have to do is to activate the virtual environment. So you will do source .env, the name of the directory, with your virtual environment /bin/activate. This is on Linux or Mac. If you are on Windows, it will be slightly different. But the thing is that you have to activate the virtual environment before installing anything inside of it. So I can activate that here. And then the next thing that you should do is make sure that you upgrade the version of pip. So you do Python-m pip install upgrade pip. And this will make sure that you have the latest version of pip installed in your virtual environment. Many errors while installing packages, and that you see like, oh, error compilating, like compiling something or like building something. Those errors are in many cases just because you have an old version of pip, but the error won't give it away. So just make sure that you have the latest version of pip. After that, we can install the dependencies that we are going to be using. So we're going to use this file requirements. Where is it? I lost it. Here it is. Requirements.txt. I have a bunch of dependencies here. This is what we're going to use. There's a bunch of ideas that you can have about how to use dependencies, how to pin them. We are not going to talk about that today. We're just going to install this like this. So we are saying we want to install FastAPI with the extra optional requirements. All this includes Unicorn, which is the server that is going to run FastAPI. We're going to use it in a second, and some other additional dependencies. Then this is what we need for FastAPI, and then we're installing the dependencies for the machine learning stuff. So about the machine learning stuff, this is what we are going to use. You are going to use the Stable Diffusions, Stable Diffusion model from diffusers, which is part of Hugging Face. You can read a bunch about that in their blog post. I'm not going to be teaching you that. We are not going to be reading all this. I already copied this code. So this code is not what we are writing, because we are not writing the machine learning part. We are writing the API part. So we're going to be using this same thing. Then we have to install the dependencies for this. That's what we have here. So what we will do is pip install -r requirements, and this is what we will type. I won't hit enter because I don't want it to reinstall all the things. I already installed all that. Then the next thing that we will do is to install the development dependencies, which are this dev-requirements, this file that I have over here. And here I have just some packages that will help me lint the code and automatically format the code. And I also use this IPyKernel package, which is part of the Jupyter Notebooks package. It's an internal part of that. And we are going to use it to create an interactive window while we are editing. So this is going to help us explore code a bit quicker. This is one of those secret tips that I think not many people have and not many use, and it's one of those amazing gems. So we have, after having all these requirements, now we can start coding. So let's jump to the machine learning part of things. So I have this file ML. I just copied the code from that blog post and I just put it here. This is what we're going to use. So we're going to import some parts of the code. We're going to import some libraries. And then for Hugging Face, we need to have a token. So I put the token in this file, token.txt. I'm not going to show it to you because it's supposed to be private. But then I'm reading it with this path, and I'm reading the content in this variable token. This is all that this is doing. Now, let's actually explore all this thing live. So I'm going to select this first line, and I'm going to say Control-Shift-P to show this command interface. And I'm going to say Jupyter run. This is the option that I'm looking for. Run selection or line in interactive window. I actually have it with a shortcut of Shift Enter. So I'm going to hit this, and this is actually going to start an interactive window here on the side. This is the equivalent of a Jupyter notebook. So I have a kind of a Jupyter notebook here that I can interact with, and I can interact from the code directly. So actually, let me hide this. Now we have this here, and I can actually interact with this thing from here directly. I can create a new path, for example. Just hit Shift Enter, and then it's going to create that object there in this interactive window. But I can select lines of code. Let me hide this on the side. I can select these lines of code and just import those different packages by selecting them and shift enter, which is the shortcut that I have. And this is just gonna send them to the notebook here on the side. Give me a second. Now, this is important here. This is gonna take a little bit because it's just importing the whole torch and everything. But after it's done, you can see that we have the check mark there. Now we can select the token path and we are gonna load the token here. Now we are also importing here, we're importing the Stable Diffusion pipeline from diffusers. This is part of Hugging Face. So we're gonna create a pipe, which is gonna be a Stable Diffusion pipeline that is reading from a pre-trained model. So I'm gonna select this whole section of code and I'm gonna run it. I'm gonna send it to the Jupyter Notebook or to the interactive window that I have here. The first time that you run this on your local machine, this is going to take a while because this is actually downloading all the weights for this model, and it's a quite a big model, so it's going to take a while the first time you run it. I already ran it, so this is actually being fast. It's just that the model is really big, so it has to take some time to load everything. And you can also see that I don't have to select all the line. I can just like put the cursor on some line. Oh, by the way, you see these red squiggly lines? Those are telling me that there's probably an error in my code. Normally, that's what those squiggly red lines tell us. In this case, it's just that there's a little thing that is not correctly written in the source code of this Stable Diffusion pipeline. Something that could be improved there, but anyway, it still works. Also, I don't have to select the whole line. I can just like put the cursor anywhere on that line, and as long as it's on the line itself, I can shift enter, and this is gonna send that to the interactive window. So you can see that this is being sent here. This is still gonna take a while, so we're gonna wait for a little second for that, and we're gonna start playing around with FastAPI while this finishes loading the machine learning model. So I'm gonna create a FastAPI application here. We're gonna do it from scratch. So we are going to import from FastAPI. We're going to import the FastAPI class. And then we're going to create an app. It's going to be a FastAPI instance. And this object is just an instance of this app. Then we're going to create this app.get, and we're going to define a function that is going to be just this. Yes, thank you, GitHub Copilot, for the suggestions. So this is what we are doing. We are telling, hey, FastAPI, whenever someone sends a request that goes to the root path and it's an HTTP GET request, an HTTP GET operation or GET method, I want this function to be the one that handles that. And I want you to return this content, which is just this dictionary. And this is going to be encoded automatically as JSON by FastAPI. So we just write this. If you have never seen this @ symbol, this is equivalent as if we said something like this. Hey, I want you, app.get, I want you to take this function, read root, and do whatever is it that you are doing there. What we are doing with that @ symbol is roughly equivalent to that. So we are just saying, hey, FastAPI, I want you to do that thing that you do when you get requests to the root path. Do that with this function. Now, we are going to continue with our code because the machine learning model is already finished. So we have this pipeline that was loaded. And then we also sent the pipeline to CUDA. We wanted to be executing on the GPU to be a little bit faster. So now we can play around with this. Let's actually move this a little bit to the side. So we're going to create a prompt, which is this one. So I'm just, let me move it to the top so you can see it better. And I'm just sending this to the interactive window. So we have the prompt variable there. And now we can, let me uncomment this line because this is the line that we are going to use. Let's select this line and we can execute it. And what we are doing here is, hey, I want to use this pipe to process the prompt. This is going to execute all this heavy machine learning model that is going to take a while to process and to load and to do everything. And then this is going to generate some result. That result contains a dictionary that has a sample, and then we can take the first one of that, and that is going to be an image. This image is some particular type of object, but this is what is going to contain the actual image that we are going to be using. So in these variable images that we are going to have the generated Stable Diffusion machine learning image. Now, the thing is, if we have this just here like this, it will mean that if in the main file we were importing all this code, then this will be running every time we try to import that code. So it will run every time we just load the module. And you can see that this takes a long while to process. We don't want this to be running every time. We just want it to run whenever we call it. So we need to create a function. That's what we are doing here. We're creating this function obtain image. And you can see that this is just doing exactly the same that we are doing here manually. It's just that we are doing it inside of a function, and then we are passing the extra parameters that it can receive. So we are saying, here's the pipe, and this pipe is going to receive the prompt, and it's going to receive some additional parameters. And these parameters, we are just taking them directly from the same function that we are creating to pass the parameters. The seed is just going to make, actually, this is done. Let's actually see what is the image that we got. So I can select this variable image, and then I can send it directly to the interactive window. And then it's going to execute that. And then we see, oh, this is a fancy astronaut riding a horse. Nice, very cool. And it's actually kind of flying. So I guess the astronaut is actually flying the horse or something. I don't know. Anyway, now we can put this logic inside of this function. This is what we actually really want. So we can comment this part out. And then now the seed is just like, what is the random generator number? We can fix that so that we can get always exactly the same image generated from some particular random number. The number of inference steps is how many times we want the model to process the thing to improve the results of the generated image. If you lower this, we're gonna get a crappier astronaut, but it's gonna be a lot faster. And you can read about all these parameters on the blog post. The thing is that we are just taking those parameters and just using them inside of the code here. Now, we can select this function and we can execute it on the side so that we have the function available. And now we can just to check that this is actually working. We can uncomment this line and we can generate the image again, but using our new function that is going to be able to generate this image when we call it, instead of just like whenever we import it. We are just saying, hey, I want the number of inference steps is just 5. I want you to do some crappy random astronaut, and I want the seed of the random number generator to be this one. So I want you to give me exactly the same astronaut, the same crappy astronaut every time. So we can just select this line and then we can execute it. And this is going to take a while, but it's not going to be as long as the first one because this is having a number of inference steps that is much lower. So now we can see what is the images that we got. And we can see some psychedelic weird random astronaut on some random weird horse. Nice, amazing. This is all we need for the machine learning side. We don't want to generate this image every time we load this module. So we can comment this part out and we can just save this. And we don't need this interactive window anymore. We already have the function that we need. And we know that this is actually working because we were running each thing step by step. We've run this whole thing even once here. So we know that this is working. We can just like close this. And now let's actually play with FastAPI. So we have this code here. This is actually a completely valid FastAPI application. So we can now run this FastAPI application using Uvicorn. The way we use Uvicorn is that we call Uvicorn, and then we pass this string main:app. This string main:app, that is the parameter that we pass to Uvicorn, is equivalent to this. Let's say that we are telling Uvicorn, hey, Uvicorn, I want you to, from main, import the object app. So main is the thing that we are importing. Then after the colon is what is the thing that we are importing from that module. This app is the same app. If we go to the definition, it's the same app that we created here. So we are telling Uvicorn, hey, I want you to start the application using this object app. This is all this means. Now, if we run this code, we can actually close this file. We don't need to save anything there. We run it and we say that Uvicorn is running and is running on this port, on this IP and this port. So we can actually go and follow this link. This is going to open here and we can see that we are receiving. Let's move this to the side so we can see everything at the same time. We are receiving the response that we were expecting. Hello world. Nice. Cool. That's working. Okay, so let's actually try and do something else. We're going to get an item whenever someone sends a request to /items/ and this thing is going to be a path parameter. So let's see what that means. But first, let's create a function that is going to read this. I'm going to remove this because we just need the item ID, and we're going to return the item ID direct. So whenever someone goes to, let's say, /example.com/items/foo, this foo this will be variable. This will not be a fixed URL. This foo will go in this item ID that is put in these curly braces. The curly braces are the same ones that you use in F strings, but this is not an F string. This doesn't have the F here, and it cannot have the F because this is not a variable here. But you can see that it uses the same curly braces, so you can remember what is the format that you need to put there. FastAPI is gonna read this URL and it's gonna extract the part that goes in this part of the path. Is going to extract it because it knows where to extract it from this definition here, and it's going to put the value of this foo inside of this parameter. We are telling it that this is an integer, so this is actually going to be like an integer, like this. So then we are going to have inside of this parameter, we're going to have an actual integer like 7. So now let's actually save this. And if we go in the URL here, we go to /items/7, it's going to say, hey, this is not found. This is because when we started Ubicorn, it was actually with the old version of the code. We haven't restarted Ubicorn reading the new code. So we have to stop Ubicorn with Control-C or, Control-C also on Mac. And then we can start it again. But now I'm going to use this trick of --reload. This is something that you should not use in production. This is only for development. But this means that we are telling Ubicorn, hey, I want you to check the files. And whenever I change them, I want you to restart automatically the server. So now this is loading. And now I can refresh this page. And I can see that now I'm receiving item ID 7. And because this is reloading, now I can change things here. Like let's say I want a message, and the message is going to say hello world with a single quote. So we have this message hello world, and if I save it, this is going to reload automatically. So let me save, and you can see that this, you can see the has a warning, watch file detected changes, reloading, blah blah blah, shutting down, starting. This is now restarted automatically. So now we can refresh this page, and we can have the new message hello world that we were expecting. So nice, this is working quite nicely. This is great for development. Never use it in production because it takes a lot of memory and consumes a lot of the resources of the machine, but it's great for development so you can interact quickly with your own application. Now, let's say that we want to, also, I was forgetting something. So this item ID, what we receive in the code, this is actually an integer. Because we are, because we are annotating it with this colon int, then the editor is going to know what is the type of this parameter. So we can say item ID dot, and we're going to get autocompletion for integers. We're not going to get autocompletion for strings or for something else. The editor knows that this is going to be an integer. And if we try to do some invalid operation, like summing an integer with a string, then the editor is going to be able to tell us, hey, you are doing something that is not valid. You cannot sum an integer and the literal string SDF. So the editor is going to help us a lot just by using the type annotations. But FastAPI is also going to make sure that we actually receive the data that we were expecting. So if we instead of items 7, we go to items foo, and we go there, then we're going to receive an automatic error. The client is going to receive, the client in the browser is going to receive an automatic error saying, hey, you have an error in the path, in the item ID, which is a path parameter. The value is not a valid integer. So this is not a valid integer. So the FastAPI code here is actually in this line here is protecting us from running code with invalid data. So the data that we receive is going to be valid, and it's going to be checked and converted by FastAPI. Also notice that this is a URL. If we put that 7 here, it's part of the URL, and a URL is just text. So FastAPI is also doing automatic data conversion because this is naturally a text. URLs don't have a data type. So FastAPI is converting the data to extract that information. Now, the coolest part, I guess, of FastAPI is that if you go, we have been just like interacting with this, typing the URL. But if you go to /docs, then you get this nice automatic documentation user interface for your API. You can see this is based on our own code. So we have, here is the main get that just returns hello world, and here's the get items item ID. And we can actually try it out. We can type something here, we can type 7, and then we execute it. And when we get the response from our server that is running here, and we get the response here with the data item ID, message hello world. Actually, we don't need this message hello world anymore. This was just for the demo, so we can just save it again. This is reloading. We send the request again, and now we get the new response without that message. So we can interact live with the API that we are building, and that can help a lot. Now let's actually send somebody to this request. So, but FastAPI is built on top of two libraries. One is Starlet, and the other one is Pydantic. So Starlet does all the web parts, and Pydantic does all the data parts. You normally don't interact with Starlet directly, but you interact a lot with Pydantic directly. And Pydantic is even great, even if you're not building web applications, just for general data validation. So we are going to import from Pydantic. We're going to import a base model, and then we're going to create a class inheriting from that base model. So we're going to create a class item that inherits from base model. This is going to have a name that is a string, a price that is a float. We don't want this offer. We want something, we want tags. We want to have a tags that is going to be a list of strings that by default is just an empty list. So we are just defining what is the data shape that we expect to receive. And now we can use this class in a new path operation. I'm calling this a path operation because it's a combination of a path like this one and an HTTP operation like this one. You can also call it a root or an endpoint or however you prefer. But because in FastAPI, you normally have the two things together, the path and the operation. I'm calling it a path operation. So now we're going to create a new one. This is going to be app.post. Now, this is a post one. This is whenever we send an HTTP post operation. And this is going to say, I want to create an item. And this item is going to be, this parameter item is going to be an instance of the class item. This is standard Python type annotations to do that. Now I can save this. This is reloading automatically. I can refresh the documentation page, and I can see that now I have the post here that takes the items, and I even have the automatic example showing the data with the same shape that we defined it here. We have the name that is a string, price is an integer, well, actually a float, and tags is going to be a list of strings. If I send some data, so foo, bar, whatever, execute that, I'm going to receive the response here. Now, if let's say I remove the tags, I just send this like this. This is still going to work because the tags have a default value of an empty string. So this is still working. But if I remove the price, I try to execute it, then this is also FastAPI is going to tell us exactly where the problem is. Inside of the body, the price field, this was a field that was required and you didn't send it. So it's telling us it's doing the automatic data validation based on the data shapes that we define. So we can define arbitrarily nested data structures however we need. And FastAPI is going to do the validation of that for us. Even if we do deeply nested data structures. So for example, we have the tags that are supposed to be a list of strings, or in terms of JSON, it will be an array of strings. And let's say that instead of passing a string, we pass a JSON object, or the equivalent is a Python dictionary. So this is going to be name, foo, and we try to execute this. FastAPI is also going to do the data validation for that. It's going to tell us inside of the body, inside of the tags at index 1. So index 0 will be this string, and index 0 is fine, but index 1 is the one that has a problem. Index 1, a string type was expected. So we get all the data validation, even for deeply nested data structures. Nice, that's very cool. So this is quick overview of FastAPI in general, of the kinds of things that you might need. Now we're going to actually do the machine learning part. So now we're going to get app.get, we're going to get a generated model. So let's say generate, no. Oh, I told you that you were going to see typos. Generate, no prompt yet. We're going to generate an image here, and we're going to receive a prompt. Now we are saving this. Let me reload this page. And you can see that we have here the new endpoint or the new path operation, generate. And now this prompt, because this prompt is not part of the path here, this is going to be read from the query parameters. You can see that this goes from the query parameters. So I'm going to try it out. Hello. If I execute it, you can see the query parameters are these things that go after the question mark. So we are telling it, hey, I want the query parameter called prompt to have a value of hello. So we are sending the query parameters here, and that's how we just define it. If it's not part of the path, then FastAPI is going to extract it from the query parameters. Now, we just got the prompt. We just need to return the actual image. So what we are going to do is that I'm going to stop Ubicorn because I don't want it to be reloading every time. And I'm going to import from ML, import obtain image. I don't want Ubicorn to be reloading because whenever this line is run, from ML import something, then this whole file is going to be executed. this is going to execute the creation of the function. It's not going to execute the function itself. It's not going to call the function. So this line of generating the actual image, this is not going to be called. For the creation of the function is going to be called. The creation of the function doesn't matter, but loading the model is going to be quite slow because the model is slow. So we don't want Uvicorn to be reloading the file every time we save something and then just like taking a long time to reload again and reload again and reload again. So that's why I stopped Uvicorn and removed the reload. Now, what I'm going to do is that I'm going to use that obtain image prompt. And I'm going to say, hey, I want to have an image that is going to be equals to obtain image of the prompt that I received in query parameters. And I'm going to have the number of inference steps is going to be 5. This is just the same small number of inference steps. And we're going to have the seed, which is the same fixed one. Just to make sure that everything is working, we want to have like a simple version first. And then what I'm going to do is that I'm going to save this image. So image.save. And then I'm going to save it in a file, image.png. And then I'm not going to return a JSON dictionary. I'm going to return a file. So I'm going to, from FastAPI, those requests, I'm going to, from the kernel, the responses. Yeah, I'm going to import a file response. And then here I'm going to return a file response with the same image. And that's going to do it. Now I save it. I can restart Uvicorn without reload. And I can run this. And you can see that Uvicorn is taking a little while to load because it's loading the whole machine learning model. Now it has to load the whole machine learning model whenever it reaches this point in the code. Now this is going to finish at some point, and then we're going to be able to reload here. If I refresh the page, this is not going to run because Uvicorn hasn't finished it. And then, okay, this is done. Nice, amazing. Now we can generate it. So let's try it out. Let's write the prompt. And the prompt is going to be a photograph of an astronaut riding a horse. Let's copy this prompt. Let's generate that. Let's execute that. And you can see that this is using the divide CUDA. It's generating the image. It's taking a while, and then it's generating the image, saving that to a file, and then returning us the file. And we have the nice random astronaut on the horse. This is not the coolest one. Let's actually build the coolest version. So we have this thing to generate the image, but we have a bunch of parameters that we can receive, and we want to pass those parameters here. These parameters are taken from here. We can actually copy all these parameters just as is. We can just copy paste that into this function. We can just copy paste them, and actually let me format the code. And now we can use all those parameters inside of our function, the function that we created. And let me format the code again so that we can see that. So we take the seed, we take the non-inference steps, we take the guidance scale, and because all these parameters are just type annotations, FastAPI is going to be able to extract all that information from there. So now we're going to save it. We're going to stop Uvicorn. We're going to reload Uvicorn. Let's start Uvicorn again. This is going to take a little bit to load the model again. And then we're going to be able to use this code. So let's see what we are doing. We are taking the same parameters. So seed is going to be an integer that can also be none. By default is none. Because it has a default, then this seed is not going to be required. If we take the num of inference steps, this is an integer. So FastAPI is going to validate that we actually send an integer, or that we don't send anything because this has a default value of 50. Let's actually refresh this page because this is already done. And you can see that now we have all the parameters here. So you can just try it out. Let's try it out with the same prompt that we were using, photograph of an astronaut riding a horse. Give me that, and we just execute that. We're gonna execute it. We're gonna get this is the real thing. So just brace yourself. This is the cool astronaut riding a horse from a web API that we are building. And this is just taking a while because this is a massive machine learning model that is burning my laptop. And it's probably gonna lift off before we finish the streaming. So this is processing that. It's gonna generate a very cool astronaut. While this does that, let's actually see what are the things that we have here. So we have the seed. We could put the seed here to fix the type of astronaut that we received. We have the number of inference steps that has a default value of 50. We have the guidance scale that has a default value of 7.5. We could change it, or we can just like leave it, or just like not even send it, and then FastAPI will use the default values. because this has all type annotations, then FastAPI is going to do automatic data validation, data conversion, all that stuff. So we just use the same type parameters, the same type annotations that we had for the function, and we just copy paste that, and then we just use it here. And now we automatically have data validation, data documentation here, and data serialization. So this is almost done. And now we're going to see, what did we get? Okay, this is a nice, strange black and white astronaut riding a horse in a very, I don't know, kind of Western black and white style. Nice. Ta-da! We got the nice AI machine learning API. And you saw that we just like built all this very quickly. I hope so, without so many mistakes. Nice. Now let's go back to the slides for a little second. So we were talking about the code. I wanted to tell you a little bit, just very quickly, about what we were doing. We were saving the file. Actually, let me show you the code again. We were saving the file here, and then we were loading the file again. This means that if we have a client that is sending some request, and then we have another client sending another request, we might end up having the same file overwritten by one and the other, and like we don't want to send the file for one request to the other. We could have then random names for the files, but that will also mean that we will be reading and writing to disk, even though we actually don't need to read and write to disk. Normally, reading and writing to disk is a lot slower than doing it from memory, so we could want to do it from memory. In this particular case, it wouldn't make that much of a difference because the machine learning model is just taking so long because it's so heavy that writing or not writing to this is going to be negligible. But if we have like a faster machine learning model or something like that, we will probably want to avoid reading and writing from disk. And what we could do will be to import a streaming response. And then we could import IO, which is this standard library module. And then we can create a memory stream, which is kind of a fake file in memory. And then we can save the image to this memory stream in the format PNG, because this doesn't have an extension. We have to tell it explicitly, hey, this is PNG. They will tell the memory file object, hey, go to the beginning of this file because we want to send the whole file, not the end that doesn't have anything. And then we will send that in the streaming response class here. Also telling it the media type is an image PNG, because again, this doesn't have an extension, so it cannot infer what is the type of the object. But like, yeah, anyway, this is just like the a little bit more pro sort of version where we don't even read and write from disk. We just like do everything in memory. Nice. So a little bit more about FastAPI. What's this thing about performance? So this is a benchmark run by a third party called Taking Power. They compare a bunch of different languages and a bunch of different frameworks. These ones that I'm showing you are Python and Golang. Go are the green lines, Python are the blue lines. Go is a compiled language, so Go has to be faster than Python. Nevertheless, FastAPI and a bunch of others get to have performance that is comparable to at least some of the Go frameworks. So this is quite nice. And this is while staying on the comfortableness of Python, where we can do all the machine learning and cool stuff. Which one is the fastest is not necessarily that clear. Ubicorn is the server that we were using to run FastAPI. Ubicorn is not a framework, it's a server to run the thing. So Ubicorn will have to be on top of everything because Ubicorn is running everything below. But anyway, it has just some random noise. The cool thing is that it has 15,000 requests or something. So that means it's over 9,000 requests per second. The thing is that you can get like kind of the best on the ballpark of the best performance that you can get in Python while staying in the comfort of Python and getting like all these additional features about data validation, documentation, serialization, and all the stuff. FastAPI also has a bunch of additional features that you can use: dependency injection, security, auto integration, WebSockets, files, background tasks, templates, easy GraphQL integration, like all the things that you will expect from one of these frameworks. Is just that FastAPI is optimized for building web APIs, which is the main type of thing that we are doing with web frameworks lately. And that's it. Thank you very much. I think we can probably jump to the questions.
Wow, Sebastian, that was fast and totally awesome. Thank you for walking us through that. And, I think we've got a nice chunk of time to get at some of these questions. Thank you, everyone in the audience, for asking those questions. Feel free to go into Slido, keep upvoting, keep asking questions that you're interested in hearing from Sebastian about. So yeah, wow, very, very cool stuff. The first question we've got that is by far the most upvoted is, can we have a link to the repo with a template project? And Sebastian, I think we've actually started working on that on our side already. So we will definitely, I think, make sure.
Absolutely. We will share the code afterwards. Just like make sure to follow deeplearning.ai and FourthBrain, because they are gonna share like the final code of this whole thing that we were playing with. But like, yeah, absolutely.
Yes. And, come back, rewatch the video on half speed and try to live code it again. Cause yeah, that was awesome. Okay. So the next question is, what deployment options for FastAPI web app are available? Is there any difference in the way the app needs to be packaged for serverless versus a virtual machine? For example, AWS Lambda versus AWS EC2?
Yeah, so if you are running the thing yourself, you're running a command directly, as it will be running on EC2 or running on a Docker container or running directly on a machine or on Heroku or something like that, where you can tell which is the specific command. You just tell, hey, I want to run the command Uvicorn, and you tell Uvicorn what is the application that you want to run. So FastAPI is built on top of a standard called ASGI. This is a standard for Python for building async web applications, async web frameworks, actually, and the communication between the server thing that is Uvicorn and the framework thing that is FastAPI. So FastAPI is based on this standard, so you can just like use the common techniques that you will do. If you want to run on a server system like AWS Lambda, then you will use another application, another package that is called Mangum, that just wraps FastAPI to make it compatible with the specifics of AWS Lambda. If you are doing that on Google Cloud, that will be Google Cloud Run, which is just a Docker container, so you just tell it to run Uvicorn directly. And also Azure is also building a bunch of things to support directly ASGI applications and to have like a very good support for FastAPI. The same with all these other providers. Most of these providers have a way to support one of these mechanisms to run it. But normally it's very simple. Normally you just run Uvicorn with the app directly, and that's it.
Very cool. Okay. The next question we've got is about scaling. So can you talk a little bit about best practices for scaling up, handling, hundreds, thousands of requests happening in parallel?
Yeah. So, well, first, I recently, well, like I don't know, some months ago, I revamped all the documentation in FastAPI about deployment and like what are the actual core concepts that you need to have. It's actually even independent of FastAPI that you need to take care and think about. Requests per second, what is the request, what is latency, you need to take care about memory and CPU and like the ports and like what are the things that you're actually thinking of. Then what are the mechanisms to deploy? How do you deploy that if you do it manually, directly? How do you do that if you do it in containers? All the stuff. It's like quite long and I won't be able to say everything here, but in general, you are normally running some type of system that is normally scaling. You're normally running like, I don't know, some type of containers or some third-party tool that is scaling your application automatically. So if it's Lambda, then they are going to take care of run multiple instances of the same thing. If it's Kubernetes or something like that, then you're going to have containers that you're replicating outside of the process. So you will normally have a single Uvicorn program running a single FastAPI application without workers, without any wrappers, just that directly, and then you will replicate that container multiple times. This on the horizontal scaling, to be able to have many FastAPI applications that have your same code all running at the same time and being able to handle like any load that you need to send them. Now, about having squeezing performance of a single FastAPI application, the thing is, the recommendation will be just write your normal code. That's one of the things that I probably didn't mention. FastAPI is actually an async framework underneath. So if you write async and await, async and await functions, then FastAPI is going to be able to run them and like do all the high performance stuff. But you don't have to do that. You can write normal functions, and FastAPI is going to take care of do the smart thing to not damage performance. The technical terms are to not block the main event loop on the main thread. If you don't understand that, don't worry. I don't fully understand that either. But the thing is, you can use async and await functions or normal functions. If you use async and await functions, you need to make sure that all the packages that you use inside of those functions are actually compatible with async and await, so that you are not blocking that. For example, reading a file and then it doesn't have an await, then Python is just gonna be waiting for that, instead of just going and handling another request at the same time. That's the whole benefit of async and await, is that Python can handle many requests during the same period of time. If you need to squeeze performance, then you can just make sure that you use async and await, and that the libraries that you use are compatible with that. Then you can, if you need to squeeze more performance, you can avoid having FastAPI automatically serialize your data, because in FastAPI you can return kind of any type of object. Sometimes you can even return like objects that come from the database, and FastAPI will do the best job it can to convert that to JSON. But if you want to squeeze performance, you can make sure that you convert it to JSON directly and that you return a response directly. And you can, instead of using the standard JSON response, you can use JSON response using ORJSON or JSON, which is a package that serializes JSON and is written in Rust, so has much better performance, and is part of the FastAPI included responses that you can use. So there are a couple of tricks that you can do to squeeze performance as much as possible. But the first thing that you will probably want to do is just write the simplest code you can and just scale horizontally. Just add more nodes, just like add more containers to that. And you're gonna get far away with just that, before having to squeeze performance in the code itself. Like, you're gonna have clients and you're gonna have income before you need to go and squeeze the actual code internally. So like, yeah, if you're just building something, just write standard code, and whenever you need to increase the throughput, then you can just like scale horizontally and just add more nodes or more containers.
Love it. Love it. Yeah. Wait until you have clients and wait until you have some revenue coming in to worry about scaling. So I want to follow up, double clicking in on this sort of async development. Marcio Oliveira asks, what is the best approach to retrain the model we have trained outside our application? And also, what is the best way to load them asynchronously?
That's like, the thing is that's something that there's no, oh, this is the way. There's still no perfect way. It depends a lot on the team. It depends a lot on the approach. It depends a lot on how you are doing things. So for some people, it makes sense to use a third-party service that just serves machine learning models for some particular frameworks with some particular layers, and they are compatible with that. And then like, you are fine with that, and then you can just like load the model there. And then you can have a FastAPI in the middle that will be kind of a proxy between that thing that is serving models, and it's just like doing all the authentication and handling all the requests and just resending that. That helps for some people. I have seen a lot of people that what they do is that they need to be retraining quickly, and they need to have a bunch of different models, and they need to be able to have them isolated. So what they do is that they train the models, and then they have them packaged like in whatever is the standard format for that model in a file. Then they create a Docker image with that machine learning model inside of the Docker image, and then just load them all inside of the FastAPI application, and everything is in a single container. If you do it this way, then there's just like a couple of things that you need to make sure you do and you don't do. So you should not load the machine learning model per request, because loading a machine learning model normally means reading a file from disk, which is very large. Reading from disk is slow, and if the file is large, it's going to be super slow. And if you do it per request, that's going to be super slow. One thing that you can do is load the model, just like load the machine learning model at the top of the module, so at the top of the Python file. That will mean that whenever you import that file, or whenever you start the FastAPI application, that's going to take a while loading that machine learning model. The only caveat is that if you have that machine learning model in some particular file that is part of your whole application, and you need to import that Python file from different places, then all those places are going to end up, the first place that imports that file is going to end up loading that whole machine learning application, that whole machine learning model, and that's going to take a while. The super duper trick that you can use is actually use a utility from the standard library, from the Func tools library, the tools for functions, that is called an LRU cache, which is a least recent used cache. You add that decorator on top of a function that will return the actual model that is loaded. And then the next time you call that function, it's actually going to return the same object that it returned the first time. So it's just going to load the model the first time you call it, and then it's not going to call that again. That's kind of like the advanced trick that you can use if you need to optimize that type of thing. You can read more about that in the FastAPI documentation about settings. Is not related to models, but it's also reading from files. So it's kind of the same trick. You can do that if you need to handle all the different possible use cases. It's just that it's a little bit more advanced, but probably for the first use cases and for the first things that you do, you can just load the machine learning model at the top of some Python file, and that will probably be the easiest and the best way for a long while to do.
Okay. Stay away from loading it per request. Yeah, I love the very simple rules that we're getting out of this, and obviously there's a ton of advanced things that we can do. Okay, the big question. Here we go, Sebastian. Okay, FastAPI versus Flask for building ML and AI web apps. What's your take? What's your hot take on this?
So, like I don't know, there's a lot of discussion, FastAPI versus Flask, and like I think that the main attention, the main focus should actually be on like, hey, Flask goes like up to here. Flask has done a lot for us. Like there's just appreciation for Flask. If you go to the FastAPI documentation, there's a section about inspiration and alternatives. And like there's just like a lot of inspiration that FastAPI has taken from all these previous frameworks that have great ideas, and FastAPI is just like trying to take all these ideas and put a bunch of these ideas together in the best way possible. So yeah, like Flask has taken us a very long way. The thing is, with FastAPI, you get some extra advantages probably that are particularly applicable to modern code building APIs. If you are not building an API, if you are just rendering HTML on the backend, it's just probably gonna be like kind of the same. It's not gonna, you're not gonna see like, oh, this is much better than the other. It's like, well, more or less. But if you are building APIs, then FastAPI is probably gonna help a lot more, because it has a lot of the things that you normally need for APIs, like data validation, data documentation, data serialization. It's all based on standards. It's all based on these open API standards, which also means that you can generate clients automatically for any programming language, because this is all based on the same open API standard. There's also documentation for that in FastAPI. And it's all based on the standard type annotations, and it's also async and await. These are, for example, some of the features of modern Python that were not even available when Flask was created. So Flask had no way to be designed to take advantage of that and exploit that. So it's like just some of the advantages of like, it's just like newer. So it's been able to take advantage of all these new things. So that you can get like auto completion, inline errors, and all the stuff everywhere inside of your code. But at the same time, you get data validation, serialization, documentation, and all those things. You can probably see like there's a whole section of the FastAPI features, and there's a section about alternatives and inspiration. And you can see like also like what are several other frameworks and how FastAPI learned some of the things from those frameworks to try to apply them again here in this way. The other thing is, if you are already used to working with Flask, then FastAPI is going to be very similar, because FastAPI inherits a lot of the design from Flask. It learned a lot from Flask, and actually recent versions of Flask copied some of the designs of FastAPI. So like, I guess we just kind of cross-pollinate with all these ideas. But the thing is, if you're already used to Flask, you can probably just read the tutorial on the first page of FastAPI, not more, just that. That's going to take like 10 or 20 minutes, and that's going to be enough for you to decide like, I like this thing, or this doesn't make any sense. That's going to be enough for you to evaluate if you like it or not. So it's quite an easy investment, just like 10, 20 minutes to see like, do I like it or not?
Love it. Awesome. And, I think, you even mentioned when we were kind of doing a run through, automatic docs, the best part. And I think this is something that we've seen a lot in our courses at FourthBrain. Is that's what people love a lot about FastAPI is the automatic docs. I don't know if you had anything else to add to that, but that's certainly what I've noticed.
No, yeah. Me too. Like, like I built this thing to just to satisfy myself. Like I was using Flask and I just wanted some extra things. So like I wanted to have those and I enjoyed that a lot. But like, yeah, like going back to the question, like I have been hearing more and more teams in part, even more in machine learning, I guess, because machine learning is in many cases just APIs and like not even much more. I have been hearing like more and more that teams tell me like, whenever we're building something new, it's like by default directly with FastAPI. So like we have previous tools and previous parts that are built with Flask, but if we are building something new, then that goes directly to FastAPI just because like that works better for them. Or they also migrate some of the things from Flask to FastAPI. But like, yeah, of course, there are many Flask applications already deployed and like they are just like working fine. But in many cases, when you're building something new and you want to take those advantages, like it probably makes sense. And I actually do like the docs a lot. Like I'm probably not a very good programmer. I need to have auto completion and inline errors, and I need to be able to have like the browser telling me what are the parameters that I can set. Oh, right, it was his name and like all that. So I need to have all the help I can get. And like I built FastAPI to give me all the help I could get because like, yeah, I need the help from the tools.
Yes, awesome. We have one or two more questions here. Okay, we're gonna get super tactical with this one. This is highly upvoted, and it's a common point of confusion. We're talking about Anaconda versus virtual environment directly in Python. So it said your command line says you're using Anaconda. Is there a reason why you're also using virtual environment, venv, and pip at the same time?
Yeah, no. So just for this tutorial and for what we saw, disregard the fact that it's Anaconda or not. It's just because this is the old installation I already had, so like it's just like already there. But I'm not using any of the components of Anaconda itself. It's just that I had that installation, but I'm not using any of the internal parts of Anaconda. If you are building a project, like it will probably depend on a lot of the projects. So Anaconda in particular, the package manager from Anaconda has some particular benefits when building tools and when installing pre-built binary tools, when those are available in Conda Forge. In particular, for example, if you're in a new architecture, like one of the new Macs, an M1, in many cases, they don't have precompiled wheels, which is the standard format for packages. They don't have them available. But there's some version available for Conda. So you can install those with Conda. In those particular cases, it's probably like a very useful tool. Or when you have dependencies that go outside of Python itself, of the Python ecosystem, if you have R dependencies or things like that. But in most of the cases, you're probably good enough and probably better off with just like plain Python and using virtual environments or pip, or even if you use a tool that helps you manage virtual environments like Poetry or something like that, but that is still in the same ecosystem of pip that installs from PyPI. And that installs with the same pip mechanisms and all the stuff, because you get like the latest versions of Python and the latest official versions of those packages and like all the stuff. But in some advanced cases, like you will probably end up needing to use Anaconda or Conda, or if you need to have like some environment that is just like pre-installed with everything and you are just using them, that you're not really installing packages or things like that, in some of those cases it might work. But like, yeah, if you are just like building a project, it probably makes sense just to use virtual environments in some way. It could be what I was showing you. I was just showing you the simplest case, which is with the tools that come with Python, but you could use some tool that helps you manage all that at the same time, like dependencies, virtual environment, and installation with, for example, something like Poetry that helps you do everything on the same package. And there are some other alternatives, but like, yeah.
Love it. Yeah. When in doubt, always just keep it as simple as possible. Sebastian, wow, I've learned so much today just listening to you. I cannot believe how much content and questions that we were able to get through today. Thank you, everybody, for your questions. And Sebastian, thank you again so much for your amazing presentation and answering really everything that the audience had to throw at you.
Thank you very much for inviting me, and thank you everyone for staying. I hope that was fun and enjoyable. It's a massive pleasure to be here with you all. I'm here with FourthBrain and deep learning today. Yeah, that's so cool.
Yes, absolutely. This has been amazing. Very, very cool. This And, this brings us to the end of today's event. So what a great high note to end it on. Brought to you by FourthBrain and Deep Learning AI and Sebastian, creator of FastAPI, Tiangolo. Give him a like, give him a follow, like and sub to the deeplearning.ai YouTube channel down in the link. Deep Learning AI is going to send out a follow-up with a survey for all attendees. We'd love to hear how to make future events even better. Select 100 attendees will receive a promo code as well for a 1-month subscription to any deeplearning.ai course on Coursera. One last giant thank you to you, Sebastian, and to all of you joining us today. We'll see you all next time. And until then, keep learning.